This meeting is being recorded.
This next problem from Chapter 1, Problem 28, asks us to identify whether or not these compounds below have a molecular dipole moment. So that's the key term here, that it's a molecular dipole moment. Because we know that we can have polar bonds, polar covalent bonds in this case, and they can actually cancel each other out. So we're going to look for the overall molecular dipole moment if it exists, and then note the net dipole moment direction. So in this first example, A, I have drawn the structure out ahead of time, and we see that we have a carbon-hydrogen bond, and that's not particularly polar, that's pretty nonpolar due to the difference in electronegativity between carbon and hydrogen. But we see that we have 3 chlorine atoms, so each of these 3 bonds would be kind of pointing in this direction towards the chlorine. So the overall net dipole would be something like this, right? So we would see it in this direction. In our second molecule here, we have the 2 methyl groups. So those are all just carbon-hydrogen bonds. Again, not particularly polar in any sense, but we do have this portion here on the oxygen with 2 lone pairs. So the 2 bonds between the carbon and oxygen would be pointing in this direction. So our net dipole moment, the direction would be in this direction. Next, we have an ammonia molecule. So we have some NH bonds. So each of those would exhibit some type of polarity between hydrogen and nitrogen, all pointing in this direction. And then we also have this lone pair on top. So the net dipole for this molecule would be pointing in this direction. Next, we have a central carbon, and then we have, these should be bromines, actually. Sorry, so we're going to replace these with bromine atoms. So we have 2 chlorine and 2 bromine. So what I had drawn before was carbon tetrachloride, and I'll come back to that in one moment because all of those bonds would be equal, carbon to chlorine. But in this case, we do see a difference in electronegativity between carbon and bromine and carbon and chlorine. But overall, chlorine is more electronegative, so these bonds will not cancel each other out. So we're going to see one dipole in that direction. This bond would be in that direction. So our net dipole moment for these, since these are smaller dipoles for the bromine than the chlorine, our net dipole moment will be pointing in this direction. But as I mentioned with carbon tetrachloride, if all 4 of the surrounding atoms are equivalent, each of these bonds would be equal, and the net dipole would be 0 because all of the polar bonds would cancel each other out. So next we have molecule E. I drew out the hydrogens, but all the carbon-hydrogen bonds, these will be nonpolar, so we can just ignore those for this question here. We see 2 lone pairs on oxygen, and definitely these carbon-oxygen bonds would exhibit polarity. So our net dipole for this molecule would be in this direction. So next we have a symmetrical type of molecule here. So we're going to see an equal magnitude dipole in opposite directions, even though I did not draw that. Nearly equal in magnitude. I'll try a little better. There we go. It's a little better. So we see these vectors of equal magnitude. So this will cancel each other out, and we would have no net dipole for this one. That was our first. So this next molecule, it has 2 very polar groups here, these carbonyls, but the net dipole will exist because this molecule is not quite a mirror image, it's not quite symmetrical, so our net dipole moment will exist in this direction. Last, we have another symmetric case here. So we're going to have equal magnitude in opposite directions. So for molecule H, there's also no net dipole moment. So there's, I believe, I through L. There's 4 more that you can try on your own.